Hi, welcome to another junior geometry video. In this video, we're going to change our tact and look at what we call transformations. Transformations are when objects change. And the first transformation we're going to look at is reflection. Now, a reflection is a transformation where the object is reflected across a line. This line is called the axis of symmetry or a mirror line. And when we reflect it across the line, we create a mirror image. Right, so let's have a quick look at this example. We have the mirror line or the axis of symmetry. We have the object, some people like to say the original object or the old object. And then we have our image, some people like to say the new image. Now, it's important to note that when we do reflection, if we're using shapes like triangles or whatever other shapes, polygons or just single points, that if we have points, they get labeled like this. Point K, after it gets reflected, becomes K dash, K with a little dash above it. Point L, after it gets reflected, becomes L dash. That way we know L reflects across to L dash. And the same with M. M reflects across and becomes M dash. So try and master this labeling as quick as you can, please. Right, let's get out of here and into GeoGebra and chat more about reflection. So here we go. Let's start off with just a single point. Point A has been reflected across this mirror line to get A dash, right? Now, if it's just a single point, keep in mind that if we are 3 squares away from the mirror line, then A dash has to be 3 squares away from the mirror line, all right? So let me just show you what I mean. If A is 3 squares across the mirror line, away from the mirror line, so is A dash, right? If I was to get a little bit trickier and make my mirror line on a bit of a diagonal, look at this. Now, look at this. A is 1 square on the diagonal away from the mirror line, and A dash is 1 square away from the mirror line on the diagonal. Right, let's step up to reflecting a line. So here we have, let me just fix this up for a moment. Here we have a line X to Y, line segment it's called. And we are reflecting this line segment in the mirror line. So point X gets reflected to become X dash, and point Y gets reflected to become Y dash. Once again, same thing. Look, if we have X, which is 3 squares away from the mirror line, then X dash is 3 squares away from the mirror line. Point Y is 1 square away from the mirror line, and Y dash is 1 square away from the mirror line. Now, if I got a little bit trickier, let's just do this. Let's do this. If Y is on the mirror line, here's something just to be aware. If Y is actually on the mirror line, then it doesn't reflect anywhere. Notice that if Y is on the mirror line, it doesn't reflect anywhere. So Y dash is on the mirror line as well. Right, what else? What if Y was across the mirror line? This is an interesting question. If Y dash was across the mirror line on the other side, then notice Y dash has to be reflected across the mirror line as well. All right, let's step up to a polygon with 3 sides, a triangle. So let's just move things around a little bit and get my bearings, take the constructions away for a moment. So here we go. Here's our triangle KLM, and it gets reflected across here to L dash, K dash, and M dash. All right, so same thing. Look, L is 1 square away from the mirror line. L dash is 1 square away from the mirror line. K is 1, 2, 3, 4 squares away from the mirror line, and K dash is 4 squares away. Same thing before. If M was on the mirror line, M dash would be on the mirror line, and if M was across the mirror line, so would M dash have to move. All right, well, hopefully that's given you an insight into reflection and what it's all about, and you can get away and practice this more. So thanks very much for watching.